Well, welcome back, everybody. Two videos back, did a video on 300 Savage loading 168 grain Spear Gold Dot and the Hornady 165 grain boat tail soft point. Turns out, didn't like the boat tail soft point at all. I like that Gold Dot. The only two serviceable groups we got for the day, one okay and one good, were both with the Spear Gold Dot and Vitavori N540. However, numbers not good. That's when I started looking at all that brass, and that's what led to the second video, which was converting a whole bunch of 308 Win brass over to 300 Savage. So I cut it to size, formed it, and now it sits in these loading blocks. Those 100 that you see there on the bench, those are all neck turned. After a couple discussions with a couple of guys that are in the know, I started to really look hard at the measurements. I put a course of Scotch tape around the neck of a loaded round in the 308 Win converted brass, and then covered that in Sharpie. That gave me 4 thousandths. That Scotch tape was exactly 2 thousandths thick, so wrapped all the way around gave me 4 thousandths. When I put it into the chamber of the rifle, it did scarify a lot of the black Sharpie marker off of the tape. And then at the very end of closing the bolt, I could feel the slightest resistance, and I just didn't like it. I think it's a bit too tight. I'm thinking that I've got just less than 4 thousandths clearance between that 308 Win brass and that chamber wall. And that's just too tight for me for this particular setup. I don't want to push this rifle. I don't want to have a poor release adding to higher pressure spike. I don't want any of that happening. So to remedy that, initially I was going to load, say, 3 rounds of the next two powders we're going to utilize here and not turn the necks and shoot them, and then have 3 that are neck turned and shoot them alongside them. And then I sort of abandoned that whole thing, realizing that there was a lot of inconsistency in the neck wall thickness on that converted brass because it had been shoulder brass that had been worked up into the new neck. It wasn't going to work out, I don't think. I think it was best just to invest the time. And so I went ahead and turned them all. And I've got a couple left here to turn just so I can show you my method for turning here on this Hornady neck turning, trimming, I don't know, whatever they call it, the Hornady machine with a cordless drill. And I'm sure there's a guy or two that would say, well, if you've got just in under 4 thousandths clearance between the walls of that loaded brass and the chamber, you've got enough room. And that is actually true. However, these rounds are loaded with like 5 thousandths, 5.5 thousandths of interference or holding force or neck tension, however you want to go ahead and skin that cat. That's what bothers me. There's a lot of brass, and I understand that you're not making any more brass when you expand it. But what I want is a reliable and clean release of that bullet. I feel like at, say, 3.5 thousandths clearance with that much interference and neck tension, there's not a whole lot of room for stuff to go anywhere. There's not much room for it to travel. I would rather take another thousandth off of each of these, which is exactly what we're doing. We're knocking these down from about, I don't know, 15 thousandths neck wall thickness, 15 and a half, and we're knocking them down to right around 14. So we're not making them skinny. They're nothing like the 300 Savage stock factory brass. That's much, much lighter. We're still leaving them heavy, just not leaving them as heavy. And in the process, what I have found is we're getting way more consistent measurements when I measure around a couple of these case mouths. I feel better about that as well. And you can probably see I had the concentricity gauge out, and I was spinning a few of them, and I was coming up with a couple of them had a max of 1 thousandth run out, and a lot of them were half a thousandths. So 5/10 thousandths. So I'm happy with that. Really good news there. I think they're turning out really good considering I'm using a cheapo Hornady toolkit. Nothing wrong with it. It's not an extravagant one. The mandrel is tight. These are sized, and because they're a heavy wall and they're sized just so that they're actually tight on the mandrel, I have to force them over the mandrel on the neck turner, which is a good thing in this situation. It's keeping them really centered, and that shows when I was working them on the concentricity gauge. So this is going to be a little unorthodox. I've got my sizing die set up, already dialed in here in the press. Everything else I did in a batch. So they were all lubed and all that stuff together. And I kind of forgot about these extra pieces here that I've got in this bin. So how I'm going to manage this right now for the sake of showing you the process, it's going to be a little odd. And then I'm going to take one, I'm going to turn the neck down, I'm going to clean it out. I'm going to lube it right next to the press with some one shot just so we don't get a stuck case. I'm going to run it up in there and size it again. Why? Well, because that mandrel is bigger than our case mouth currently. And so when I push it over that, I'm expanding or changing the dimension. I don't want to do that. Or if whatever effect I do put on it with the mandrel, I want to reverse it by putting it back up in the sizing die. And because you know me and you know I got rabies, I'm going to spin that casing and send it up in a second time. Then what I'm going to do is go through some dimensional validation. I'm going to grab my caliper with the comparator gauge in it. I'm going to check where my shoulder height is. I'm going to check my overall length with another caliper. And then I'm going to go ahead and have a look at my neck wall thickness with the micrometer. Do that all in one step. So here's how the process goes for me doing this. I like to throw some one shot on the mandrel and a little tiny bump in the case mouth. Everybody's different. I appreciate other people's way of doing it. This just happens to be mine. I'll run it in one pass, two pass, and the third pass I'll take my time. It's actually not bad looking for such a cheap device. Like if this was some big name, big money device, you'd expect that, but I'm sort of shocked that it comes out that well. Brush the neck out just to make sure there's nothing in there. And this is the odd part that normally no one would ever do. But guess what? Today, that's how we're doing it. Only have a few of them to do this way. What I say now, dimensional validation. See what our numbers are. 925. So we're half thousandth long, looks like. On here we're a half thousandth under. So that's odd. Half thousandth. Not going to worry about it. This is the cool one. We started out with these casings around 155. $139.5, spinning about 180. $138.5. So we're actually under 14 here. That's fine by me. Good numbers. Smaller neck. On the money, that one. On the money. Let's see where we're at on the neck. $140.5. So 14 and 5 100,000ths. We can forgive that. 140.5. Same. I'll bet there's people screaming right now watching this saying how wasteful on the one shot. And you're right. Um, I just don't like to torch these cases going in there. It gets hot if you don't. And it's particularly when you've got to push them on like this. But they look nice. It's a good cut. Little dimensional validation. Every single one. And if you're going to ask the question, yep, every single one of these that I neck turned, I handled this exact same way. Every last one got measured. And I did end up having one with a long neck, which was very strange. I really couldn't understand that. I don't know if I just failed to trim it or didn't trim it correctly or what, but I went back and trimmed it. So there's 139.5. So like 14 thousandths. This tool is only a few minutes to set up. It ain't rocket appliances. I did trash one casing in my testing, but it was one that I already didn't like. It was sort of my suspect piece. So I sacrificed it for that. Shouldn't have to sacrifice it. I got a little greedy and cut in way too deep. This was on the money. I love it when you get them in parity like that. So 140.5 or a half a 10,000. Yeah, same. So around 14 thousandths. Happy with that. That's good news. That's a lot less if you think about taking 3 thousandths or, well, thousandth and a half off of each side. Put that around the circumference. You've got 3 thousandths difference there. That's big. So the next thing I did was I went ahead and loaded a dummy round after I had turned the neck. And so before we had 0.3400 and now we got 336. So we're 4 thousandths smaller. I like that. So take that 4 thousandths, add it to the 3.5 that we already had in the chamber outside based on the Scotch tape test. And you still got 7 thousandths there. Now here's the goofball part. I'm getting 331, sometimes 331.5, 332-ish with the 300 Savage brass in the dummy round, not turned. So there's a big difference yet there. Like I said, I could have turned these down more. I didn't want to. I think I've got them right where I need them. And I don't want to give up any more space in there if I can avoid it. And who knows, maybe the little extra neck tension and holding force we get out of the heavier wall, maybe it's helpful. Maybe we find that it gives me wild numbers or really poor groups. I don't know. It'll be something to blame at some point for certain if that becomes the case. That'll be investigated and I'll cut them down even farther if I have to. It's, it's a few hours of time or a couple hours, but it's not the end of the world. So I busted out the blue hammer of broken dreams and offloaded both those dummies. I no longer need them. I'm going to reuse these projectiles. I noticed with the 300 Savage brass, one blow with the hammer on a good wood block, and I was able to unseat that bullet. But this bullet that was in the dummy with the 308 Win conversion brass, it took 3 blows and it came out rough. And I can see the difference on the jacketing here. I'm not sure if that'll be visible. You can see a little more polish on the surface of that jacket. That's a lot more neck tension. But from that, we're going to get into loading for this next test, and we're going to be testing 2 different powders. They're a little different. They're not anything like one another, so it'll be similar to the last test in that we had very dissimilar powders. We'll be loading for the 300 Savage with the 168 grain Speer Gold Dot, utilizing TAC, and we will also be loading that bullet with Varget. Both of these will be short ladder tests. They're upper middle of the load range. We're staying under max on both of them, obviously. I decided not to start very low, having investigated other people's loadings in this same rifle, and I understand that that is nothing to work off of. But couple that with what I studied on Gordon's reloading tool, I'm pretty happy with what we have. So, like in Varget, we're going to be starting at 37.3 grains and making 0.3 grain bumps up to 38.5. In TAC, we're going to be starting at 37.7 grains in 0.3 grains, and we'll be ending at 38.9 grains. So we're going to have 5 groups of 5 loadings of each. So we got the Super Trickler going. Deep into the Ramshot TAC group, loading 37.7 grains up to 38.9 in 0.3 grain increments. TAC cycles pretty well in the Super Trickler. Not always perfect, but pretty good. Here we're looking for 38.9 grains. We'll see how close you can stick it here this second attempt around. Went over again. 200s. Like I said, if this was plinking ammo or even hunting ammo, that wouldn't bother me. But for the sake of testing, I want it right down to 38.90. So I'm going to accept a couple rejections the way it goes. I went to sort this brass by weight, and it was absolutely hysterical. They're all so close, it's not even worth even attempting. It's a big waste of time. So far, seating has been really smooth. Shouldn't say so far. 20 rounds now. 20 plus. I did my ciders already. Seating's been very smooth. I like the way these necks feel. I was going for a 2.018, and there I'm 5/10 thousandths over. Not going to worry about that. That's what I like to see. Right on the money. Well, I can get a 0.5 thousandth under if I push hard enough. Should be the last round, and then we'll get a powder change. Over to Varget. All right, switched over to Varget. About midpoint, working on our 5-step little mini ladder. Varget being a slightly longer kernel extruded powder, it's a little trickier to get dead nut zero on the Super Trickler, just the way it is. And to answer the obvious question that'll arise out of why only 5 charge weights? My God, it's such a small sample.
And you're right to assume that. Bottom line is I'm just trying to keep the round count down. This was my grandpa's rifle. It's quite old. It has a lot of rounds on it already, and I would just like to keep the use as low as possible. I get it. A 300 Savage is not a barrel burner. I mean, it's even slower and cooler than a 308. But I just want to keep the usage down to keep the longevity there. I want this to make it several more generations. So the less I shoot it, the better condition it remains, and perhaps it lasts a little longer. To add to that is the fact that I think between these two loadings that we have here, one of them is going to be good. I don't have any fears for what happened last time. Last time was a bunch of unknowns. This is a little more known data here. On the money. I'll make the bump to our final charge, 38.5. Kind of odd, so it seems to hit that first charge real fast. I don't know what that's about. All right, out to the range, make them fly straight. Okay, we got the usual target at 100 yards, shot marker system in place, up and running, and a target cam ready to go. A little editing after the fact. You're going to see some of these shot groups look like they're in a different position on the shot marker than they are on the actual paper, groups 5 through 8 or so, maybe 9. And this was because massive water built up on the sensors on the shot marker. I was shooting in between torrential downpours. So just a side note there. I still got my measurements correct and posted the data here with all the shot groups.
Well, not much to look at, but plenty to see here. I fell flat on my face when it comes to matching the velocities that were predicted in other people's loadings and the software that I utilized, Gordon's reloading tool. But I got to fall on my sword here and admit that I modeled all of my data off of a similar but not same bullet as the 168 grain Speer Gold Dot, because Gordon's reloading tool didn't have that bullet in its library. It has not been updated in years. Some interesting patterns in these groups with the Ramshot TAC. You see how bad it starts out. 37.7 grains gave us 2,376 feet per second, SD of 14.8, and ES of 45.3 with a horrible 2.71 inch group. The next group, it looks like it starts to come together at 38 grains, but still very slow, 2,394 feet a second, SD of 8.5, and an ES of 25.9, respectable numbers, a 2.02 inch group. It threw the fifth shot of each of those first two groups low and right. The third group, 38.3 grains of Ramshot TAC, gave us 2,418 feet a second, but great numbers, 2.8 and 7.2. Very respectable, any loading. A 1.27 inch group. And I'll also point out that I completely shanked the first shot. But even if you remove that first shot, that's still an inch group. It's a 1.01 or 1.02. I can't remember. Very close to an inch. Serviceable, yes. Ideal, no. And yet again, speed still too slow. So then you go up from there to 38.6 grains. We got 2,438 feet a second. SD of 9.3, ES of 26.7. Okay numbers, but a terrible group at 2.24 inches. And there you see the vertical and horizontal spread. The final group, 38.9 grains of Ramshot TAC, gave us 2,442 feet a second, SD of 13.8, and ES of 43.1, and a 1.49 inch group. It almost looks like a group is beginning to come together there. I really want to explore a little bit hotter on the TAC side. We're still well under pressure. We're seeing no sign at all. All indications from the data that I've looked at in every other tool and book is that we're below what we would see pressure at anyhow. On the Varget side of the house, we had a couple, three groups that actually turned out pretty good. One that's fantastic. But we started out at 37.3 grains of Varget, gave us 2,267 feet a second, god awfully slow. SD of 20.1, an ES of 56.3, and a 1.43 inch group that's very vertical. Very next group, 37.6 grains, gave us 2,283 feet a second, SD of 14.1, an ES of 43.3, and a 0.87 inch group. Very good group, a little bit horizontal for my liking, but a good group nonetheless, albeit far too slow. Next group, 37.9 grains, gave us 2,292 feet per second, SD of 13.6, ES of 34.3, and a 2.25 inch group that was back into the vertical. The next group at 38.2 grains gave us 2,298 feet a second, SD of 14.3, ES of 45, a 0.98 inch group that's starting to look a little more like a group again rather than stretching out into the horizontal and vertical, sort of a combination of the two. The last group, 38.5 grains of Hodgdon Varget, gave us 2,343 feet a second, SD of 12.7, ES of 32.3, a 1.04 inch group, and back into the vertical, however, much closer together. And you can see the point of impact shift as it gets higher and higher, eventually up near the bullseye on that last group. But once again, speed's far too slow to do anything with there. Varget is another powder that I'd like to explore hotter yet with. We're well under pressure and we're very low on velocity for what I was looking to get out of this. Having modeled it under a different bullet, I got some very poor data and as a result got very slow speeds. It bears noting that the 38.3 grains of Ramshot TAC, the middle group in the upper column there, that's the best group for that powder for the day. It's also at 2,418 feet a second. And when I went and looked back at using the same bullet with Vitavori N540 at 39.5 grains, we got 2,406 feet a second. So very close to that 2,418 with good numbers, 4.5 and 11.4. That shot a 0.8 inch group. I'm thinking that there is something to be said about that velocity. Somewhere in that little range is a good spot or a node where they like to come together. Barrel timing notwithstanding, because I honestly don't know what the difference is between the Vitavori N540 and the TAC in that load at those speeds for barrel timing. However, they both shot their best groups at around that speed. Notable. So there's plenty of work left to be done. A couple good groups today. I'm pretty happy with those. I'm not going to leave this test disappointed aside the speed. I understand that the SD and ES numbers on the Varget are basically like that because we're getting burnout, full burnout of powder after the bullet has already left the barrel. So we're not getting a complete burn. With TAC, we were getting 100% burn, and we still had some funkier numbers, but we had a few that were pretty good. We had 3 groups in a row there that were SD under 10. So that's notable as well. So the bottom line is we're going to continue pursuing this bullet. We're going to move these ladders up a little bit into the hotter range. We may go to smaller increments, maybe not. We've got a lot of room left to work with. We're going to hit pressure with TAC long before we're going to get there with Varget at the point we're at now, if we make that our starting blocks. In the meantime, our brass is great, looks perfect after firing. I'm really happy with how it turned out, and I'm not going to blame it for anything at this point. I think the numbers are the numbers. They don't lie. This is based on the powder bullet combination and the velocities we're getting. More on that later. So thanks for stopping by, everybody. I appreciate you being here. Look for another video in this series shortly. We'll be pushing these up a little hotter and then eventually onto other stuff. Look forward to seeing you in the next one. Until then, take care and shoot straight.